Okay, just working through exercise 4E, page 250, 3D trigonometry. This is one of those vertical mast questions. Remember, we always draw a diagram, starting with question 3 here. It's meant to be the base there. Okay, so point B is 37 metres from the base of the mast, whereas point A, they've given me the cable length. And A is find the height of the cable, no, height of the mast. Remember, if you don't have a diagram showing just the right angles, you do need to draw it, just the right angle triangle. We'll obviously use the triangle with A in it because we have more information for that. We only have one piece of information for this triangle. Label your sides, choose your ratio, substitute your values, rearrange, use your calculator. Question B wants the angle to the horizontal of the cable going from B, so that means this angle here, so to the horizontal of the cable. We draw our triangle again. We now know that H is 37.609. Whoops, we don't know that one. We know that. And I want to find B, opposite and adjacent. We're using tan. Choose your ratio. Use inverse tan to get the angle. And that is our angle. We want the angle to 2 decimal places. Now remember that because you had to round to get this answer here, you have a rounded answer there, and technically we should have more than 3 decimal places since it's a 2 decimal place answer. So there's a problem here where actually we should have kept a couple of extra decimal places. Okay, question 4A, we're finding height of the clock. So we use just the triangle that matters to us for the question. We could have used, we're using B because that's given me the angle, and B is 28 meters away from the clock. Label your sides. Now, I'm going to need the next answer to 2 decimal places. I would give my answer as they asked for 3 decimal places, but there's nothing wrong with giving the unrounded answer, or at least keeping more decimal places, because for a 2 decimal place answer in the next question, I should keep 4 decimal places if I'm going to use this answer, which I am. Question B, I want the angle, so it's exactly the same as this question here, quite frankly. Angle to the clock face at point A. I now know the height, and I'll keep 4 decimal places in there, and I know that A is 36 meters from there. Label your sides. Substitute your values. Rearrange using inverse tan because it's an angle. Decimal places. Question 5. We have a rectangular prism. They want us to draw a triangle ABF. And for question A, they want, or AI, they would like angle BAF. Well, we've got opposite and adjacent again, lots of tan. Now, 5 over 10 is a half, so you are quite welcome to write that as a half there or leave it as 5 over 10, whatever works. And in fact, I would expect that after a little while, you would automatically know what angle has tan of a half. No, I wouldn't, because that's one of the few where there isn't a good one. Sorry. And we want to find the length AF. Now we've got a right angle triangle here with 2 sides, so there's nothing wrong with just using Pythagoras. And they've asked for 2 decimal places. They'll often get a request for exact values, and of course if it's exact values you'd leave it as 5 root 5, but since they've asked for 2 decimal places, and we are in centimeters. Draw the triangle AGF. Now we just found AF. Now, if we're going to use this, use the exact values. Do I have AG? No, I don't. And we want to find angle GAF. That's that angle in there. Label our sides. There's a little extra bracket in there for. Find the length of the ramp. Remember, I'm finding an unknown on the bottom. We switch these in our rearranging. Ah. Now, remember I kept that extra distance there, but I only want 2 decimal places. And then that horizontal here. Again, you could use trig for this, or you could just use Pythagoras, because we have both sides now. But keep 4 decimal places in this if you're using that length, because we now know that. By using the formula with the square root in it, it reduces my working. Or it would if I hadn't left this dratted little extra bracket in there. And I called that X, didn't I? Question 7, triangular faces of a pyramid. Okay, so we want the perimeter of the base of the pyramid, which means we need to find one side, and we'll actually be finding half of one side, which is X, which if you look at the question is from the center of the pyramid out. And then we'll have 2x for our side lengths, and we'll have to get 4 of those. Label your sides, choose your ratio, which is tan. Substitute your values. Unknown is on the bottom, so it will end up as a division. Exact values, but we have been asked for 1 decimal place. We're in meters, and the perimeter is 4 times the side, which is 4 times 2x, which is 4 times 2 times 17.3. I'd use that increased accuracy there again, and I've just deleted that, so that's 30 divided by 10, 60. Yeah, keep more accuracy here. We want answers to 1 decimal place. We don't want this rounded one here. 2 lots of that for one side, times 4. And remember, I'm keeping more of that there. So I had 3205 in there. Just for interest's sake, if I'd had 17.3 times 2 for the side length times 4, 138.4. I'm out by 0.2 because I rounded here. That was the answer they wanted, but you want to keep more decimal places if you're going to be doing more calculations with it. So I would have an error of 0.2 there, which, you know, if I was buying stuff for the outside of the pyramid and I ordered exactly that much, I'd be short. Always add 10% if you're ordering materials. Question 8 is a Tentpole question. Oh, look, it's almost exactly the same as the flagpole and the clock tower, but hey. Distance of the base from peg A distance from peg B find the angle at peg B formed by peg A, peg B and the pole. Okay, so there's our pole. Peg A and B are marked as being at right angles from each other, so this is a view down. And we are finding the angle at peg B. And we're putting in the information that we have. So we have the distance from pole to B here. We have the distance from pole to A. And as always, I kept more decimal places there. Deeply annoying writing all these numbers, I know. And then we want the distance between peg A and B. I'd use Pythagoras. And that's 20 minutes, that's enough work.